of this conference. And we've talked about change, about transition, but this also means that we might have to rethink the business models, contracts with customers, and just to make it work financially. And how can we make district heating competitive in the future? This is what this block is going to be about.
And to answer this question, I have the pleasure to introduce to you Dr. Kristina Lygnerud, Economia Doctor, Head of the Energy Group at IVL Research Institute. What you might not know about Kristina is that before being a brilliant district heating researcher, she studied art history in Florence, and on her spare time she travels around Sweden with her children for hockey games.
You wouldn't know how many ice hockey parlors there are. Yeah? What a fantastic introduction. It was the first time I've ever had that, so thank you. Very nice to see that there are so many left after the afternoon coffee break. So I'm Kristina Lygnerud. I work at two places, the Swedish Environment Research Institute, where I work with the Energy Group and the Energy Department. And I also work at Halmstad University together with Professor Sven Werner in his group. And what I will talk to you about today comes from both workplaces. So we're going to think about how district heating can be competitive in the future by using excess heat in different formats. First, we will try to position where we have energy in the smart city context that the EU sees. We will talk about excess heat, the potential, the challenges. And then we will see what happens if we innovate the waste heat recovery and go into LowTEMP. The Reuseheat project will be featured. And then we will try to answer if we can become more competitive when we use excess heat. So what does the EU say about the smart city? It's pretty interesting when you read their homepage, because they talk a lot about smart cities, having digital technologies which translate into better public services for citizens, better use of resources, and less impact on the environment. A smart city is a place where the traditional networks and services are more efficient, with the use of digital and telecommunication technologies for the benefit of its inhabitants and businesses. And here we come to energy. It means smarter urban transportation networks, upgraded water supply and waste disposal facilities, and more efficient ways to heat and light buildings. So, the EU thinks that a smart city is energy efficient. So that's great. But I think that a smart city also uses its excess heat. So let's see. Is there any potential for excess heat recovery? Today we know that about 30 petajoule per year is being recovered in some areas of Europe, but very little is used in district heating systems. The top country that does it is Sweden with 9%, but also Denmark, Finland, France, Germany and Russia are active in this field. But there is potential. In Sweden, the main industries that produce waste heat are paper, coke and refineries, chemicals, and non-metallic mineral productions and basic metals. So, making use of excess heat necessitates that the provider of heat goes beyond the core business, which is a challenge because maybe you don't want to invest in something outside of your core. How can we influence them to do that? And the district heating provider is in a difficult position because there becomes an external dependencies on external supply of heat. So it's not an equation that's completely easy from a business point of view. We know that there are barriers to waste heat recovery. If there is no district heating network, well, then there is a big problem. We have cost competitive supplies of heat. We have policy incentive for other forms of investments, for example, bio or waste-fueled combined heat and power. Sometimes the technical solution become more complex than foreseen, and the lower temperatures than foreseen can also be a problem, and the pipes can be costly. Those were technical problems, but there are also humans involved, and then we have less tangible barriers, like the interaction. What is the quality of the heat? What should the price of the heat be? Well, in summer, it's probably not worth so much to the district heating provider as in winter. How do we come to an agreement here? What is the value of this product? There is an asymmetric information because the industry has certain ways of doing things. So maybe they have a standstill every year in November and then no production heat will come to the district heating provider. That's difficult, and you have to become more transparent than you're used to. It's important that you have energy efficiency understanding on both sides, otherwise there is little incentive to do it. And you have to have some kind of contract with shared incentives. Then again, there will be a competition for investment capital internally, and there is always the risk that the heat provider shuts down his or her industry, and then the heat is lost. So we have challenges. But we have seen in a study that I did with Sven that looking from 1974 to 2014 in all Swedish waste heat recoveries, that really successful waste heat collaborations are long-term, 20-30 years, and are very large in terms of volumes. So one conclusion is that excess heat recovery can boost the heating company's fuel mix and allow an increased profit. So I would say that's a direct link to increased competition. But I guess you already knew that, because this is no news to Sweden, where the first waste heat recovery was initiated in the 70s. But what you might not know so much about is the LowTEMP. But you have been talking about it all day, but maybe I can give some new insights. So if we try to recover urban waste heat, what happens then? Does it improve the competitiveness of the district heating business? Let's see what we learned from the Reuseheat project. The Reuseheat project is an EU-financed project. It's a Horizon project, 4 years. We have 4 demo sites. We recover heat from a computer center. We recover heat from the cooling process of a hospital. We recover heat from the metro system and heat from the sewage water. So what we say is, in the future, there should be a potential for cities to more or less heat themselves if we manage to recover all this kind of heat. Is there a potential? Well, in the project, we have mapped all the sewage heat, computer centers, hospitals, and metros, and we identified that there is about 1.2 etajoule per year that we could recover, which is about 10% of the EU's total energy demand for heat and hot water. So, there is potential. But then again, urban excess heat sources are different from industrial sources because they are very local, they are small in volume, they often need some kind of heat pump to work, and they are new, apart maybe from the sewage water heat recovery that has been extended in Sweden since the 80s. And often it involves a large number of stakeholders, because if you're going to recover heat from a city, then maybe the city needs to have a stake in the business. There is some kind of research agent, there is the energy provider, and there is the customer. So complex contracts are usual. Yes, so I mentioned the 4 demo sites, and if we manage to put them in place, we will have recovered heat of 5,130 megawatt per year and reduced greenhouse gas emissions of 1,135 tons per year. So a little bit more detail. In the city of Nice in France, close to the airport, there is a large construction site, which is called Grands Arenas. And it's a French national site for innovation. And there you find our heat recovery. It's a low temperature system that's being built, and you can provide both heating and cooling depending on the season. And what we do there is to try to engage the energy citizen, and we display on a large dashboard what is being recovered real time from the sewage water. Then we have in the city of Berlin in Germany, we have a station close to the Technical University where we will recover heat from the tunnels. it will go straight into the university building. This is a smaller demo site than the one that has been built in Islington in London, where they recovered heat from the ventilation shaft. The difference is that our solution does not need so much construction works, and it's more placeable in any metro station. But it's smaller in size. Then we have a data center in Germany, in the city of Braunschweig, and here we have an existing district heating network that is the backbone of the low temperature network. So if ever we have a problem to supply heat from the computer center, we can always resort to the large-scale system. And the heat is going to 400 passive houses that are newly built adjacent to the low-temperature grid. And then in Spain, we have the city of Madrid, and there it's very warm. And the hospitals in Madrid need constant cooling all year. So here we take heat from the cooling process, and we replace a fossil fuel boiler. And what we discover is that this kind of combination is no news. I mean, the waste heat has always been there, and the heat pumps are no news, but it's the combination of these two that is news. So we think that these kind of system innovations can create competitiveness, but they need some barriers to be overcome, and a change in the business logic. So what we do in the third generation, the high temperature district heating, is that we have a central production unit and a big distribution network. But what happens with the urban heat sources is that they are very local. So you have to think locally rather than large scale. And then, to be extreme, the customer has been seen as a heat sink in the large systems, whereas now we have to see it as a person we have an intensive dialogue with. I'm sorry, I just have to take some water. Sometimes my voice fails me. I don't know why. Yeah, it happened last time you were with me, Sven, so you know, right? Okay, sorry for that. Too much hockey, yeah. So, yeah, and then you're used to biofuels to produce energy, but here you have a local, freely available source often. And you need to improve the way that you control and monitor the system. Because if you start with a local heat source, then you will buy it from somebody who's also getting heat from you, so you have the prosumer relationship popping up. So you have to change the way you think about the business logic. And we see in all of our sites that our demo sites are very technically oriented. They want it to work technically, but nobody has been thinking about the business logic shift. So that means that they don't take full advantage of the values that are created, rather focuses on different barriers. And what they always mention then is that we have a low technical maturity of existing system solutions, which makes it difficult for a company to just start replicating the solution. The payback periods that we have in Reuseheat are about 15 years, and that's very long for something to become competitive. We see that there are no incentives for low temperature heat recovery investments, but rather for renewables in different forms, which means that we have a competition with that kind of activity. We have done interviews. We have done 78 interviews across 8 European countries with policymakers, and we find that there is not really any legal framework supporting the low temperature heat recovery. So if it's not in the law, how can you make a standard like you talk about? How can we make regulations that support this? And the news of all of this makes it difficult, because then we don't have standardized contracts. And if you don't have standardized contracts, it takes a very long time to get to the contract writing and to get it right. And then again, what is this heat worth and to whom? There are very diverging views of this. And the low temperature is in itself sometimes then a challenge. In the Reuseheat project, we try to identify how to write efficient contracts. So we see that the number one item is the shared incentives. What's in it for you? What's in it for me? How can we both benefit? The The details of the supply must be much more pronounced than you have in a normal contract, because you really need to know when the volumes will come and where, and if there is a problems, we need to know how to mitigate the absence of volume. We need to know who to talk to, what resources we can go to if we have a problem, how to communicate, and we need to understand each other's operational activities. This becomes even more important in the urban context than in the large waste heat recovery context. And you need some kind of renegotiation clauses and mitigation activities that come in if you have a problem. And you have to keep it simple, because the margins on this kind of recovery is much lower than on other high temperature recoveries. So if you make it complex, you will lose the entire benefit, maybe in the contract phase. So now we come to the business model. You don't know how painful it is to have to go and drink in front of so many people. I'm sorry for that. Okay, so this is when I will never stop talking. Have you seen this business model canvas before? Yes, great. So you know that the value you propose to the customers is king, right? So what happens then with the low temperature heat sources? Well, the value of green enters the business model, because the resources you recover locally in the city, they don't impact the environment. And you have a local energy source, which means that your resilience will increase. If you have a big system that is complemented by smaller islands, it's very difficult to sink the entire system. You will come closer to the customer, have a closer dialogue that is long-term. So this means that we might have a big opportunity here to create a competitive advantage. Because when everybody else is going in the opposite way, they are digitalizing, they are doing things mechanically, they have one arm's length to the customer. What the district heating providers in low temperature contexts can do is actually to get hold of the customer and get this great long-term relationship. And we can do it because we create new values. The value of green, the long-term relationship, and they start trusting the district heating company. So to answer the question of my presentation, I think that the low temperature can add more competitiveness to the business model of district heating. Thank you. Questions?
Thank you very much, Kristina. So do we have questions from the audience? Yes, just wait for the microphone, please.
So I wonder if you have to, or if you see that you have to choose between the third and the fourth generation to remain competitive in the future.
I think you will have a combination of third and fourth into the future, because one of the big advantages of the fourth generation is that if you have a system and it's at its maximum and you have some new kind of residential area or so that you have to supply, then a small island will really help to do the trick, rather than making a larger investment in your existing units. Then you will have the island approach. So I think that is the future, not the one or the other.
Thank you.
Another one? Great. In that case, I have a chance to ask one of my questions. I don't think you were here this morning, but we have 10 countries represented in the audience today. And I was thinking a bit about, when you talk from the business models, how much do we have in common between European countries, and how does really that affect replication of these cases that you've discussed?
Well, I think we have, I have done 2 studies, one of the Reuseheat project, and there we have 9 countries, or 8 countries, 16 partners and 9 countries. And then I made another study of 4 countries where we look explicitly into low temperature systems. And the one feature everybody has is that everybody is so technically oriented that they forget about the rest. So that's one common feature. But then I would say that in some parts of the world, like in the UK, where it's a new phenomenon with district heating, and they do low temperature to a higher extent maybe than anywhere else, then this private sector investment is pronounced, and then the business models become more efficient.
Thank you.
All right. Thank you so much, Kristina. Wow. So many good. All right.